All right. So, okay. Just give me a quick second. I need to compress a link just to make it easy for people to access. Okay, so we'll go ahead and get started right now. So thank you everyone for coming. And then people over on Zoom, you guys can hear me just fine, right?
We can hear you, Kevin.
Yeah.
Okay, thank you. So I realized that I didn't provide these links in a readily available manner. If you want to go ahead, just load up these two links on your computer. For the people in Zoom, I could copy paste that into the chat, but the bottom link is a Google Collab notebook. And if you're here for our previous sessions, we use Google Collab as a really easy way for you guys to work with Python, so you don't have to think about IDEs and whatnot. And the top link is a Google form for submitting answers to some of our challenge questions, which, if you're the first to submit and get it right, we will be giving you a $15 Amazon gift card. So give me a quick moment while I copy these links into the chat. Oh, does it actually say that?
You can go to like the Google form.
Yeah.
Just change it to like remove the UMN restriction.
Yeah. Let me change that quick. All right, so there might be a restriction on who can access it, so I just need to change that.
If you guys want cookies, you can just pick it up.
Okay, so if the form isn't working, maybe try going to this link that I just highlighted. Sorry, it's a little bit of a jank way to do that. Oh yeah, the questions, that's gonna be in the notebook. So as we go through, I'll get to a point where there's a challenge question, but I'll give you guys 5 minutes to try and answer the question. And yeah, if you get it, $15 gift card. Yeah. Yeah. So has everyone been able to get onto the Google Collab notebook and also onto the Google form, or do we need some time? Oh, you need the notebook?
Yeah.
Do you guys all have the form pulled up? Yes, yes. Okay. Oh, you just logged in? Yeah, let me resend. Yeah, so I just resent the links to the Pandas Google Collab and the challenge form. Yeah, it's just Numpy Panda. Oh, really? Invalid credentials. Are you logged into Google through your Google account? So you're able to get on. So are you guys all able to get onto the Collab notebook?
Not quite yet.
Not quite yet.
Can you put in the chat one more time for me?
Yeah, I could pop it into the chat.
Yeah, that, thank you.
Yeah, for the people on Zoom, we're having some issues getting people in to the notebook. Please be patient with us. Thanks. Let me see. I wish Zoom had a way where you could pin chat messages. Yeah. Is anyone else having issues with the Pandas notebook?
I just think I have a bit, like, I think I have the links to get there. Because I don't have the Zoom link or anything like that.
Oh, you don't have the Zoom link?
Yeah, just like no.
Yeah. So the link to the notebook is on the screen right here.
Oh, okay.
Yeah. So they're having issues with permission, so I want to make sure that everyone's able to get on. All right. We all good over here? Yep, yep. Yep. Is anyone on Zoom having issues accessing the Pandas notebook? Amar, you are. So what problem? Do you just not have the link, or is it saying that you don't have permission to access it?
Yeah, it's saying that there's like an error loading the notebook and it's just invalid credentials or something, even though I'm logged into
Okay.
my UMN account.
All right. Okay, let's try this new link. I'm gonna put it in the Zoom chat right now. But let's try that and see if it works now.
Yep, it worked.
That worked? Okay.
Yep.
Over here, do you
Thanks.
guys want to try this new link and see if it works?
What is it?
Nupa 2.
Yeah, with me.
It works. Yeah.
Sorry for the technical issues.
Yeah, sorry about that, but let's get going. Okay, so I'm assuming that everyone can see my screen right now. If you're here for the last two sessions, you know that we kind of bum rushed right through the basics of Python, and that's our plan today. So Numpy and Pandas, these are, if you're not familiar with Python libraries, these are basically external code bases that people have used that makes it easy to do a lot of functionalities. These two in particular are especially important for anything data science related. If that's something you're interested in at all, you absolutely have to know these, or you're not going to get anything done. And your employer will be very mad at you if you don't know these. But we'll be kind of, again, bum rushing through this, just going through enough basics so you know like what they are, kind of what they can do, and kind of setting you up so that if you want to learn more about this, you can, because these libraries are huge and there's a lot of functionality built into them. But so first things first, this is external code and we need to load these in. Typically in Python, you do that using the import keyword. So I'll try, working with NumPy, import NumPy. And something I like to do is you could type in as to rename the library. So like import NumPy as NP. That's just a little shorthand I like to use, and you'll see why that's useful later on. And then I can do import pandas as PD and just hit run, and it should work for everyone, right? Everyone's able to get that to run, right? Like I think Google Collab should have NumPy and Pandas built in already. Folks on Zoom, we good?
Yep.
Okay. All right, so I'm just gonna move on. So quick introduction to pandas. So its main features is two new data structures that we call series and data frames. So series, if you're familiar with the list data structure, it's a lot very similar to that, but they are limited in that they can only store data of one type. But each element in the list, you can give it a custom index. So you're not forced to just index using like 0 through whatever numbers. You can assign it names. And I'll just show you a quick example right here. And if you want to type along with me, I would encourage that. So let's say I want to make a list, a series of a bunch of animals. So I use the pd.series command. When you're calling a function that comes from an external library and you imported it like how we did, you would use the shorthand that you specified for that library. So pd, so I don't have to type in pandas every time, dot, the function from it, and then of course, normal function syntax. And so series, you can feed in a list and it'll convert that to a series. And then you also have this extra argument where you could specify your own custom index, and I'll just use the first few letters of the alphabet. That is not how the alphabet works. And then run that. So if I wanted to say, access the first two elements in this, I could, just do normal list slicing. So 0 through 2, that's our first two elements, and it does that. You see it gives us, the first two entries and also the associated index. I can also access things directly through their index. So like how A is associated with cow, if I looked up for the index A, it'll give me cow back. So it's kind of like a weird mix between a dictionary and a list, but you'll see more on like why this is useful. On their own, these series are not that useful, but if you look at it, you might notice that these series, they're kind of like individual columns in a large data table. Like if you think of an Excel table, you could break down each column into its own series, and then a data frame would basically just be a collection of those in a single table. And that's what people mainly use pandas for, being able to basically do Excel, but in Python. It's not very exciting, but trust me, it's very useful. Let me just check the chat because I think there's something. Nope. Okay. So I could show you how to create your own data frame. I'm not going to show you how to create your own data frame because most of the time you're going to be importing data in for somewhere else. And in your Pandas notebook, you should have this line of code here. So the data we're working with, if you know the website Kaggle, they have a very well-known beginner machine learning task where you try to predict who survived the Titanic disaster. And so we're just gonna load in that data table. I ripped it off from someone's GitHub. I don't think they'll mind, but just run this line and the data should be loaded in for you. So just going through some quick properties of data frames that may be useful for you to know. So right now it's loaded in as data and everyone's able to get that to load in. Fine, right? No issues there? All right, all good. So we can get some basic information about it, like if we do data.shape. So notice how I'm not putting in parentheses. This is not a function. This is just an attribute of the data frame. And it'll give us back a tuple that has how many rows are on the data and then how many columns. So in this case, we have 891 rows, 12 columns. If this line is not running, that means that your data did not load in. So just flag me if that happened. Okay. So then going through just accessing some other useful yep. Yeah, question. No, nothing's supposed to show up. Just try running the data. Yeah, don't worry about it. We're moving. Okay, good.
Does anyone in Zoom have any questions?
Doesn't look like it, so we could just keep pressing on.
Let's just give like 2 minutes for everyone to like write down the first few marks.
Yeah, we'll just keep moving to wherever you want time. Yep. So other useful information about the data table we can get really easily is the column names. So I'll just type in that, hit run, and what you'll see is that it shows the names of every column that's in this. So that's a quick way to get that information about your data table. There's also so let me just insert another code block here. If you want to insert another code block for whatever reason, you can just click up on here and it'll put one in. That's what I did to get this new one. But if you want to try, typing in data.info, so notice parentheses, this is a function now, and you run that, you get a quick summary of what's contained in this data frame, okay? So you get the names of each column. There's a column that says non-null and that has counts. So null values, those are missing values. This column tells you how many values are not missing in your data. So you can see, most of them, 891, that's how many rows there are. Most of them are completely filled. It's just we have a few variables like age, cabin, embarked that have a couple missing entries, and we'll get to that later on. And then you also have the data type that specifies what it is, if you were curious about that. Final useful method that I'm going to show for this part. So the head command, and if you haven't noticed, all these commands, you're calling it on the data table you want to call it on. But if you use the head command, that'll automatically show the first 5 lines of your data frame. And I believe you can mess with the inputs to this function to control how many lines you want specifically. So if I type in 6, that'll give me the first 6 lines. If I want to, that'll just give me the first 2 lines. But doesn't matter what you use. What this is good for is just a quick way to kind of visualize what you're working with without having to load in everything and overwhelm yourself. So that's just the quick basics. Do we have any questions so far? No questions. Okay. If you have questions, just shoot out, because people in person, you guys are like sitting right outside my field of vision. So I can't really see if you're raising your hands or not. So just like, I don't know, literally scream at me. Okay. So selecting data, we went over how to index through series. Now I'm going to show you how to index through data frames. It's kind of similar to series, just with a few extra steps. So you can use your normal kind of list indexing syntax, but for whatever reason with data frames, they force you to go through this .iloc thing in order to do it. So say data and I want these. So typically how it goes is, instead of just like having one number, okay, well actually if you've worked with a list of lists, you would know that this is the index of the list and then this is the index in the second list. Well, this time it's all within the same bracket. So in front of the comma, you'll have the row indices that you want. So the first, 4th, 6th row, let's say I want that. And then for the columns, I don't know, I'll just pick the first 5. I think that'll give me, no, first 6. Run that. And of course, I forget to type that in. Make sure you don't forget to type in .iloc or it's going to throw an error at you like that. You're kidding me. What am I doing wrong? Oh, shoot. Thank you. Whoops. Okay. Now I should go. There we go. Okay. So selected the right the right columns and the rows that I wanted. If you were to try indexing using only, instead of like 2 dimensions as we did here, and I just typed in like one series of number or one number, so let's say 0 through 10, it's going to automatically interpret that as row indexes. So it'll just give you back all the columns and then rows 0 through 10. Or if I like put in something like 1, it'll just give me that row. And in this case, since it's just one entry, just presented it as a series. But that is briefly how you can select data using your normal list slicing methods. You can also select out the columns by their names. So maybe I should have introduced this before, but if you type in data.name, so data.name, that directly accesses the column in the data frame called name. If I wanted the sex column, all right, data.sex, it gives me back their sex. If I wanted their age, data.age, now I get the column containing all their ages. If you wanted to maybe say select multiple of these columns using their names, you can do that too. So if I wanted sex and age, so I pass in the names of them as a list like this, and God knows why I don't need to use .iloc for this. Again, indexing in Pandas, it can get, there's just extra steps involved, and I don't know why there's extra steps, but if you want to select multiple columns, here's how you select multiple columns using the names. And so if I wanted to get really fancy and combine these together, so I'm going to use data instead of iloc. I'm going to use LOC right here. There is some quirks between, what does ILOC and LOC do. I'm not going to jump into them because A, I'm not that quite clear on it, and B, you should be able to figure it out quickly enough with Google. It's not. I don't think it's something that you really need to know off the top of your head. But say I wanted these rows and I wanted data from these columns. Boom, it worked. So, yeah, some just quick notes there. My recommendation, I think if you choose LOC or ILOC, I'm not sure that it really matters, but throughout your code, be consistent with which one you pick. Because like if you have to submit your code to like a supervisor or like a peer who's helping you, they will get pissed off at you if you use them interchangeably. So, moving on. Another nifty thing is that you can index using a series of Booleans. So if I, try something like data.sex equals male, right? What you'll see is that gives me back a series of a bunch of true false values that correspond to, is this sex, is this person's sex male? And let's say I wanted to get all the data, but just for the males. Well, that's not, that's pretty easy. Data.loc male. That is not, there's a comma. And so as you can see, the data, it only contains information for males. I use this colon there to show that I just want all of the columns in there. And notice again, I use LOC. So I guess I should say that when I am using LOC in this, if you're trying to index it in a similar fashion, just use LOC. But yeah, I think that covers most of list slicing. So I have a question here that I want you guys to try. This isn't going to be one of the gift card questions because there's 3 gift card questions and I don't have $45 to give away, unfortunately. There's 2 questions in here, so I do have $30 to give away. But I would encourage you to try, using using what I just went through to try and select the age and the passenger class, which is this P class variable, and try to select that information just for the females who also survived. And in this case, survived means that the value in the survived column is 1. So I think I'll just give you guys 5 minutes to attempt that, and then we'll move on. The constraints. So yeah, right here, select the age and passenger class of the females who survived. Yeah. Also, just a heads up, we may end up going overtime just because we lost a good chunk of time to technical errors. The last bit of this we'll be covering over the Numpy package, but I go over that pretty briefly. So if you gotta run, don't worry about it. We'll also be posting up this recording. So, you know, if you got somewhere to go, no need to stick around. People on Zoom, do we have any questions? All right. Yeah. All right, so I hope that was enough time for everyone to at least take a stab at this, and I'll go over, you know, how I did this. So again, if you're gonna use like any type of, I guess, complicated indexing, use .loc. I know I am backtracking a bit on what I said earlier, but so if I wanted just the rows where the passenger survived and was female, I can first construct a series that, you know, contains a Boolean showing whether or not they survived. So in this case, that's 1. And I could use and another Boolean series. So it says, you know, it has to be both survived and female. So data dot sex equals female. And because I just wanted the age and the passenger class, I'm just going to type in age, P class to select for those columns. Run it, and that's what we want. I could also include the columns. Let's say I want, oh, stop it, you. Survived. That is not how you spell survived. Survived and sex, just to show that it worked. Yep, all the age and the passenger class of all the surviving females. So that's how you do more complex selections like that. All right, data summary functions. So now that we can, you know, index and kind of pull out whatever data we want, I'm going to introduce some summary functions that'll help you explore the data without having to, again, load in everything and look through it one by one. Because the data we're using here, 891 rows, that's small potatoes compared to what you'd be working with if you wanted to go into like analytics or data science. You're going to be working with like potentially terabytes, millions of rows at a time. So you definitely do not want to have to dig through everything one by one. So easiest summary function I can introduce is the .describe function. So if you just want to type that in, hit run, what you'll see is it only gives results. Oh shoot, am I unmuted on Zoom? Yes, I am. But it only gives results for the numerical column, and it just computes some really basic summary statistics. How many entries are there? Or I guess non-missing entries, if you notice age is lower than everything else.
Just to make sure, like,
Yeah, the recording should be resumed. Yeah, and then like your mean, standard deviation, different quantiles. Good way to just understand your numerical data. If you guys are all familiar with what correlation is, you can use the data.core function. And that'll show how correlated is each numerical variable with one another. That may be useful too to see, do you have like any redundancy, or is there any special relationships that you may not have noticed earlier? Looking at our data, all the correlations are really small in magnitude, so there's nothing, although I guess you can see like a pretty big correlation between the passenger class and the fare they paid, which is not surprising. Class 1, you're paying big bucks. Other summary functions, you have the .min function, you have the .max function. That's just to get the min and max respectively if you don't want the entire output of describe. And of course, there's like median, count, standard deviation, yada, yada. So that's just it for data summary functions. I think that's all you really need. This is going to be the first challenge question, so you can submit the answer to this on the Google form. What I want you to do is copy and paste your code into the form response and mark that this is challenge question 1. But I want you to try and find the proportion of males and females who survived the crash, and also the average fare of the survivors for each sex. I'm going to give you guys 5 minutes to work on this, and whoever submits correct code will be sending you an Amazon gift card within the next week. So if that's incentive to work on it, yeah, have at it. Okay, so 5 minutes is up. Hopefully you guys were able to get through that. If you weren't, don't worry about it. Okay, we're crashing through this at a higher speed than normal. But I will show you guys the answer. You might get a little bit mad at me because I have a one-line way of doing this that you may not have that you probably didn't know about. I'm betting that a lot of you guys had to use multiple lines in order to get it to work. But I'm just going to quickly introduce the group by function. So what group by does is it allows you to just select. It allows you to, like, if you have what's called a categorical variable, like say sex, where every entry is either male or female, you can group by sex and then compute summary statistics for each of the unique values. And you may be seeing already how this could have made your life easier for the past 5 minutes. But before I jump into that, I want to introduce the unique function. So this is another summary function. If you remember the last ones that we went through, it only computed information for the numerical columns. For the non-numerical columns, like sex, you can use the .unique function to find all the unique values in it. So for sex, we kind of know what to expect. Male, female. If I want to try P class, it gives me all the different values in the P class column. Some variables just don't behave well at all, like names. If I try to get the unique value of every name, it's just going to give me every single name. So this isn't useful for all columns, just the ones that have a limited set of values. What's also nice is that, you can use this function called value_counts to count how many things are in, how many instances there are of each of these unique values. So like in P class, and let me just go rerun that line so it's easier for you guys to follow. Jesus Christ, that's a lot. Right. So there's that. If I run data.pclass value counts, that counts how many instances there are of each of these unique values in P class. And I could do the same thing for sex if I wanted to. Count up how many males and females there are. Just like that, easy peasy. And so, hopefully those examples kind of show you the internal logic behind how this function works. And you can implement kind of your own version of value counts using the group by function. Like I said, it allows you to apply functions just per class selection. So say I wanted, let's try running this. So group by p class, and then I run the .mean command. You do not like that. I forgot to put you in quotations. You also do not, oh boy. That'll give me the mean of all the numeric variables for each of the classes. And now you can see how you could have solved the last challenge problem in just one simple line of code like that. Here you go. So, if, let's see, I think I asked for the fair and the age or something like that. But if these values match up with what you got, pat yourself on the back, you got it right. Yeah, that's it. That's all you need to do. That's all you need to do. This is an easy way of showing you how to do it. I didn't tell it to you because I'm mean. If you got the right answer, cool, but now you know how to do it faster in 10 seconds instead of 5 minutes.
I mean, you can still use the dot log method, but just like use it.
Yeah, this is just a really easy, simple way to think about that. So now that we got through that, we're going to jump to data cleaning. Most of your time, your data is not going to come in neat and tidy formats. And if you take like a statistics class here, they'll give you all these dummy data sets where everything's perfectly ordered. There's no missing values. But in real life, your data looks ugly. The intern messed up the data entry, so there's random spaces where there really shouldn't be, so on and so forth. And in this case with the Titanic data, if you remember from the beginning, we have a lot of missing values in here. And there are ways to treat that. For our purposes, we're just gonna kind of delete those. So first things first. So if we just take a quick look at our data, we have this passenger ID column. That's not very useful to us. It's literally just 1, 2, 3, 4, 5, just showing what the row is in the data except indexed by 1. And we probably don't really want that. So what I'm going to do is I'm just going to go ahead and delete it. I'm going to use the drop function. I'm going to say I want to drop passenger ID. And then when I say access equals 1, that's saying I want to drop this thing called passenger ID, and that is found in the columns. So if why is that not working? Wait, no, I spelled passenger wrong. Passenger, oh yeah, whoops. Dot remove, I don't think dot remove is gonna work because this is like a completely new data structure, and it has its own functions.
Okay.
It might work. I'm no expert on it. I just kind of do what the documentation told me to do. Yeah. But if you see here, that column's gone now. It's no longer in data. So if I try to call data.head now, no, all right, it's still there. It's still there. It's not like lists where if you mess with it once, it's messed with forever. With pandas, you have to kind of save what you did. So I'm just going to save this in a new variable, data2. Data2 head. All right, there we go. Now it's gone. Now it's gone. And so the other goal that I kept repeating is that we want to get rid of all the missing values. And we can quickly check where the missing values are if we use this dot null function. So if you just run that, what you'll see it gives you the data table back, but it's true, false, and if you can kind of guess that if it's true, that means that the value there was originally missing. So we're going to use this later to clean out what is and isn't missing. You can also use like the opposite of this function also exists. So like data2 dot not null. That should be not null. And so now it shows you, okay, which elements is not a missing value. So let's see, they are the missing values. They are the opposite of each other. And then we can do, a quick summary of them. If you remember, Booleans, false is equivalent to a 0, true is equal to a 1. So if we run, if we take this true false data frame and then just compute the sum for each of the columns, we can quickly see which columns have missing values and how many are we dealing with. So if we just run this, we see that age has a lot, cabin, almost everything is missing, and then embarked, there's just a few. So what we're gonna do is, because we're lazy, we're just gonna throw out all the missing values. If you wanna learn how to properly deal with them, do that outside of here, because I'm not gonna go over that. I'm just gonna show you how to get rid of everything. This is definitely not like the optimal way to go about it, but it's a way to do it. So first things first, the cabin column, 687 out of the 891 entries are missing. I don't think that column's gonna have anything useful at all to me. So I'm just gonna make a new data frame where that column disappears, and I'll use the drop function for that. So let's get rid of cabin. And then because it's a column, I specify I want to get rid of it on axis 1. And then if I just take a quick look at data 3, cool. That is gone. The age column. Oh, okay. So, okay. My notes are a little bit messed up from what's on here, but we're not going to be deleting everything according to the Collab notebook I made. What we're going to do is with the age column, we're going to instead replace all the missing values with the average value. And this is going to be one of the challenge problems. And I left a few hints on here. So the task in the age column, I want you to find all the missing values, and I want you to replace it with the average age. The mean function, I think by default ignores all the missing values, so it calculates the average age of all the non-missing entries, and that's what I want you to use. Some hints that I left you, the is null function, it also works just on series 2. So if you want to use series Boolean indexing, do that. And I showed you how to use that to just access it. You can also assign things using that. So if you see this little hint that I drop here, you might want to formulate something that looks similar to that to get the answer. And again, I'll give you 5 minutes. After 5 minutes, we technically are at time. So if you need to go for it. If you want to stick around for maybe another 15, 20 minutes, thanks for that. Okay, so just a little bit of time left. Actually, yeah, it's 7:18 now, so I'm gonna call time. So if you have your submission, just go ahead and submit that now. But I'm gonna go over how I solved this. So let's see. First thing I did, I just went ahead and made a clone data frame just so I didn't mess with what we're currently using in the tutorial. I stored the average age in a variable called fill age. So data for age mean. So that'll give me the average age, and I could probably just print that out for you to show. So that gives me the average age of the passengers. And then I created a series of true false values that shows, whether or not the age is missing, like so. So calling it on the age series, call dot is null. And then if I just print that, that gives me what I want. So then what I do, data.lock, missing age. So I select all the rows where the age is missing. And then I'm working specifically with the age column. And so this accesses all the missing values in the age column, and it replaces them with the average. So then, oh, whoops. Oh, data for. So if I just go ahead and look at data for dot age, there shouldn't be any missing values. That might not be the best way to check it. Our run is null and then sum now. So add up all the missing values in there. It's now at 0. So I successfully replaced all the missing values with the average age. Another way that you could do it, using a function that I didn't show. So if I take age, I could just replace the column entirely. What I'll do is I'll use a function called fill NA. And you can call that on a series and it'll automatically fill all the missing values with something else, like say the mean of age. So if I run that and then check for any missing values in age now, oh, no more missing values. So I showed you the more complicated way to do it, and then the one-line easy way to do it. Okay, and then last thing, the embarked column, you can see here, it has 2 missing values. Since that's small, I think I'll just get rid of those data points entirely. It's only 2. It's not going to affect, whatever downstream analysis you want to do that much. So I'm just going to delete it like this. Not null. So if you're, what we did last time, select all the entries in embarked that is not a missing value, and I just want those rows. That's what I'm telling the command. Keep all the functions, and then if I take a look at data for, let's just say, okay. So I dropped all those missing things from data 4, and now looking at it, I have no more missing values anywhere. I got rid of cabin, the cabin column, replaced all the missing values in age with the average value, and just dropped the missing samples in embarked. Well, all the samples in their entirety that didn't have embarked. So that's a quick and dirty way to handle missing values in your data. Again, not the optimal way, but for us, it's good enough. It's a starting point and introduces some good functionality. So what I'm going to do now is I'm going to
Does anyone have any questions before we move on?
Oh yeah. Any questions? Yes. We have a question over here. In this code block? Below that. Yeah. So I took the embarked column and then the not null function that retrieves a series of true falses saying, is it missing or not? And what I'm doing is, since I have that list of true false now, I can pick just the rows that are true, right? Because if you index using a series of true falses, it'll only keep what's true. So all of the columns that are false, that are null, that are missing embarked, it's not going to select that. So data 4 just gets rid of those rows completely. Okay. And then creating new variables. So maybe you want to create a new column in your data. So we just want to take a brief look right now. You have sib_sp and parch. So this is the number of siblings. This is the number of parents and children. Maybe I want a new variable that's called family size. Unfortunately, making a new variable is honestly pretty easy. You could just call it like this. So family size, even though that doesn't currently exist in our data frame, I can just pretend it does, since I'm going to fill it in with new data anyways. And the family size, that's just going to be the sum of the number of siblings and the number of parents and children. So if I just want to add up those columns like so. And forgive me, but we didn't go over like arithmetic operations with series, but I think you get the gist of what's happening here. And then we take a look at our data frame. Okay, maybe ignore this. Apparently what I'm doing is not the best way to do it, but you can see we now have a new variable introduced called family size. And it's, if you want to look, it's just the sum of sibling and parch. So that's how you can create a brand new variable from your data. And just to wrap it up, now that this data, we'll just call it fully processed. You can export your data by using the toCSV function. And then you can call it, whatever you want. Titanic processed.csv. I don't know if this is going to work. Okay, that apparently worked. I actually have no idea where this saves to, since you're on Google Collab. If you were running this locally on your machine, it will just save it to whatever folder you're operating out of. But
I'm sure like it might be the Google Drive.
It could be.
Like if you go to Google Drive, you get to see like Collab notebooks for
Yeah.
and like the .csv file.
Yeah. I'm not going to do that because we already are like 15 minutes overtime and we haven't gotten to Numpy yet. So I'm just going to quickly breeze through that. But that was the easy breezy version of Pandas. Not at all comprehensive, but who cares? You're only here for an hour and a half anyways. That's not enough time to learn everything. So NumPy, what does that add? It adds in arrays, either 1-dimensional, 2-dimensional, 3-dimensional, 4-dimensional, whatever you want. These are basically, like lists, but you can only use numbers. Or I guess you can use letters, but most of the time people do this so they can do fancy matrix math. So, if you want to make one, so now we're operating out of the NumPy package. You can just create a new array. So I'm going to create what's called a vector. That's a 1-dimensional list of things, and then a matrix is 2-dimensional. You can imagine that in your head. Let's just give it 1, 2, 3, 4. So I'm converting a list to a NumPy array. Print that. Yeah. That's all that is. Right now it looks the exact same as a list. But now I'm going to try making I'm going to call this a matrix. We're going to call this a matrix. And you can, be slow and manually construct it like this. So let's say I want to make a 3x4 matrix that just has numbers 1 through 12. I could do this, make 3 different lists. And sorry, I'm going purposely fast here because I'm already way over time. And you're also, what did I do? Oh, whoops. Yep, okay. So you don't pass in individual lists. You only pass in one list. If you want to make a matrix, use a list of lists. And there you go. You have a matrix there. Sometimes, you might be, I don't know, let's say you're initializing a empty grid and you don't want any values in there and you don't want to have to go through and manually type in all these numbers. You can easily use the .zeros functions to create a list or an array that's just filled with a bunch of zeros. So if I, try np.zeros 4, that's going to give me a vector of length 4 just filled with a bunch of zeros. And if I, instead of just passing in a single number, I pass in a tuple of numbers like 3 and 4. That gives me a 3x4 matrix that's just filled with zeros. So let me just call this something. You can also mold vectors into arrays. So if I want to say, so I have the vector A right now, that's just 1, 2, 3, 4. And I want to turn that into a 2x2 matrix. I can use the reshape function. I want your new dimensions to be 2 by 2. Boom. It goes ahead and does that for us. And then let's see, indexing through matrices. Okay, so indexing through vectors, same exact thing as lists. I'm not going to go over that. But through matrices, it's just like pandas using the .ilot command. So, I built this matrix here. Let's say, I don't know, I want to get the first, I just want the second row and then the last few columns. There we go. Maybe I want more than one row. Maybe I want the first 2 rows instead. That's not going to give me what I want. Yep, like that. Easy peasy. It's just like using .iloc without actually having to type in .iloc, which is pretty nice. And then, okay. So you can also join matrices and such together. I'm just going to call this C for the sake of the example. But so you can stack matrices on top of each other using, the row stack command. So if I want to stack matrix and this other matrix I made, C. So both have 4 columns, so they should, sit on top of each other just fine. You're not going to work. Why are you not working? You have to be passing as a tuple. Put these on top of each other. And then I can do the exact same thing, but with columns. Yep. So then because they have the same number of rows, they work perfectly fine. If you try and row stack and the columns are unequal, or column stack and the number of rows are unequal, I'm pretty sure it's going to throw an error at you. But yeah, that's all I have for NumPy. Again, that wasn't really the focus of here. I just kind of wanted to introduce it to you. Basic summary of NumPy. It puts in matrices. It works like matrices, how they do in math. So if you know machine learning, it involves a lot of linear algebra. They use a lot of NumPy with that. So now you're familiar with it. Just some concluding thoughts. We barely, like I said, on the notebook, we barely like touched the surface of either of these libraries. But I think now you guys kind of have a good understanding of what it's capable of. And like I said in the beginning, all I've really done is taught you how to be an Excel monkey in Python, and I guess through more hoops than you would have to jump through Excel. Why you would want to know this? You know, of course, if you're going to do any data related work, you want to be able to manipulate your data in code because Excel is too slow. I have tried opening data tables of 2 GB in Excel. It does take forever. In Python, it takes like, I don't know, maybe a few seconds to load in, and then you can just manipulate it all you want. You can make up, you know, automated pipelines. It's just the foundation to doing data science. It's like how if you want to do fancy math, you need to learn your multiplication table first, and there's no way around that. So hopefully this is useful to you. You guys have a good idea of what's happening with NumPy and Pandas now. Do we have any questions? Because I went through things extremely fast. Okay, if not, I'm gonna finally let you guys go. Sorry for going like 20 minutes overtime. But yeah, have a good evening, everyone.
Just announcements. Tomorrow we have the second workshop of our Android series.